I'm in the process of designing and building a CNC plasma cutting table. I've posted a video on that series already, and the next video in that series will be posted shortly. But before I post that video, I wanted to just add this extra video because I've been asked the question many times over the last 20 years or so, and it relates to how I go about zeroing a mill when I'm doing 3D or more milling. And it's one of these topics it's quite interesting. It's fairly straightforward, but there seems to be quite a lot of confusion over how we go about doing it. And I just thought I'd try and cover that off and help anyone that's struggling with getting MACH3 set up for doing this. So the general concept of a 3D mill is, excuse the crudity of this sketch, but the mill itself has a 3D space, a bit like or very similar to a 3D printer. And this is the space that it can move through. So anything within this 3D space the mill can access with the tool. The tool, of course, being something like a milling cutter. Excuse the light in here, I've got it dimmed so you can see the screen on the PC, which we'll be looking at shortly. And normally when you mill something, you will mill it as a subset within that 3D space. But of course the mill needs to know where in this general space it's meant to be carrying out the milling job. So if we have a milling operation, a CNC code, G-code file, then it generally will be referenced to a position close to the stock material that we're using, and we mill away the parts we don't want, of course. When we zero the mill, it returns to a home position for the X, Y and Z. So that might be up here somewhere. So that might be 0 for X, 0 for Y and 0 for Z. But we need then to have an offset to get to the actual part and the location within this 3D space that we want to use. And MACH3 uses what are called fixtures. And if we look on the screen, hopefully you can see this, but at the top of the screen, I'm just going to raise the camera slightly, I'm not quite sure you can see high enough. So along the top of the screen we have these G-codes, and these all relate to the current status and context of the milling machine. And the way MACH3 is generally configured is when you create a new profile, MACH3 will create a new set of macro files within a subfolder. So we have the MACH3 folder, we have a subfolder called macros, and then within that we will normally have another subfolder that will contain all the macros for a particular machine that you have a profile for. And that those macros contain all the information required to allow MACH3 to properly control a particular machine. And we'll come back to some of the macros in a few minutes because they are fairly pertinent to what we're talking about here. But the first thing we do when we power up the mill or one thing we can do is click on this button that's reference or home, and that will drive the mill to all the 3-axis or 4-axis or more home switches. And you don't need to do that. In fact, quite often I don't bother referencing the mill to its own position at all. I'll explain why later. But if we do that, if I click on reference or home, we have this button here called machine coordinates, and notice they're now all 0. So that relates to the home position for the machine. X is 0, Y is 0 and Z is 0. And this will be related, or it's referred to as the G53 fixture, and that's the machine general 3D space. But for actual milling work, say for milling something like this, we will use one of the other fixtures. So the first one is of course G54, and G54 is really a set of offsets from G53 to allow the machine to run a piece of G code relative to a location other than the machine home position. And the reason he wants to do that is it just means you don't have to essentially have the raw material either in the home position or create your G-code such that it has the offsets built in for the machine. It makes the G-code more portable. The problem is, of course, that the mill needs to know, if we have the tool holder and a tool sticking out of it, the machine needs to know where the tip of the tool is. Now, the X and Y isn't too much of a problem because once we've established that, the mill can keep track of that. But if we change the tool, we might change it for one with a different length. Now, the X and Y will still be centered in the center of the new tool, and if we put a bigger tool in, the X and Y will still be centered in the middle of the new tool in the X and Y axis. But it might be a longer tool, in which case if we try to pause the program, change the tool and then restart it, the tool is just going to crash into the workpiece because the machine thinks the tip of the tool is higher than it is. So we have to re-zero each time we change the tool. There are various ways we can go about doing this. I have various mills. On the bigger mills I use tool holders, and then each tool holder I zero independently and maintain a tool table for it. But I think that anyone that's got a big enough mill to use industrial tool holders will already know all this, so there's no point in me repeating that. This is really aimed at people who haven't done much work with CNC milling or machining and wondering how best to go about setting up the mill to do their machine work. So the first thing is when we set up a mill to machine something, we've got our machine zeroed, and then we have to tell it where the actual workpiece is. So generally what you'll do is you'll just drive the mill down to a suitable location. So I'll just use an arbitrary set of locations here. And if we regenerate the toolpath, if I'll zero Z, X, Y and Z, so we've moved the tip of the tool that's currently in the machine to a suitable starting point based on the stock that we put into the machine. If we regenerate the toolpath, you'll see that it's generated this toolpath reference to the center point of the material or the milling operation, which is what I told the software to do when I generated this file. This is a very simple test file I've created just to allow me to make this video. When we now run this program, I won't do it of course, this is not attached to an actual mill, but when we try and run the program now, all the motion will use the G54 offset, which is what we've just zeroed. If we go back to machine coordinates, notice there now something completely different. This is really how far we are in the X, Y and Z axis from the machine's home location. But the G code will now use this as the starting point for all its movements. So we'll run through. The problem comes, and that's fine if you're using just one tool, that's all you need to do. The problem comes of course is if you have to change the tool partway through a program, because you either have to get the tool exactly the right length or you have to re-zero it. And this is, I think, where a lot of the confusion comes in with MACH3, and it causes a lot of people to get frustrated with it and give up, and I'm hoping to try and head that off in this video to a certain extent. And it's really understanding how MACH3 works. Now MACH3 is basically a scripting engine, and by that what I mean is for any given operation, so if we look at the G code, for any line that it decodes, it will perform a certain set of functions, and that includes certain built-in codes. So we have these G codes that actually mean something, and if you want to know what they are within MACH3, you have these buttons down here that you pull up what each one actually means and gives an explanation as to what each one's for. And the same thing with the M codes. If we bring up the M codes, one thing that's interested, and the one that is most pertinent to this video, is M6. M6 is the tool change macro. And in particular, if you read this, you don't know if you can read this, but it says M6 tool change and then in brackets by 2 macros. And I think this is where the confusion often arises, and I quite often see in forums and discussions on this people asking where to put their modified macro. Does it go in the first macro, the second, or where is it supposed to go? And this comes down to having a general understanding of what MACH3 would do. So if we try and run this, what I've done, by the way, is I've edited this file and just thrown in a couple of arbitrary tool change commands. Not because we need to change the tool, but just so I can get this to do what we want. So I'll now run this, and what you'll notice is that I click on Start and we've got this pop-up. This is not normally here, this is something I've added. But if we cancel that, notice that and this is what you'd normally get, notice the tool change LED is flashing. Again, this panel here is different from what you would normally see in MACH3. This is a modified screen set that I've made to suit my particular purposes. And that's one of the nice things with MACH3, you can modify it to suit your own needs, and it's very, very configurable, and I think most people assume that it's fairly fixed and they can't do much with it, but you can configure this to do pretty much anything you want. But this is now flashing the tool change LED. Now what it does at this point will depend on how you've got the machine configured, and if we go up to configuration and we select general configuration, top left hand corner here we've got tool change, 3 options. Ignore the tool change. If that's checked or selected, then when it sees an M6 code in the G code file, it will ignore it. It will just carry on milling. If we have what I've got here, stop spindle and wait for cycle start, then it will go through the process I'm going to explain in this video. If we have it set to auto tool change, it will do the first step in the middle option. I'll explain what I mean by that in a minute. That's where it gets a bit confusing, I think. So I've got it set to stop spindle and wait for cycle start. So it's stopped the spindle and it's now waiting for a cycle start, which is why this LED is flashing. If we click on cycle start, it will start actual milling. You can see it's moving, and we can see the machining process is underway. And normally this will be moving the tool into the material and it will start the milling operation. So we'll run this through until we encounter another tool change request. Let's speed it up a bit so it doesn't take too long. Notice here I've inserted another M6 code. It's not strictly necessary, but I put it there just so that we can demonstrate this process. So I'll wait now until this next tool change command is executed, and we've got to it now. M6 means tool change macro, T3 is just the tool number that I've told it to request. This is if you're using a tool table, for example. Normally at this point you'd have to find some way to change the tool manually and essentially re-zero it, and that's where it becomes a bit of a pain. I mean, you may have zeroed the first tool on the top of the stock material, but you may now have machined that away. For example, if you're doing a roughing cycle with the first tool and you want a finishing cycle with the second tool, you might find the top surface that you originally zeroed to is now no longer in existence because it's now bits of swarf all over your workshop floor. So the way I've set up my machine, I've written a couple of macros, and one of the first things it does within the first macro is it throws up this selection box. If I just click cancel, it is the same as the macro not being there, it does nothing. In fact, it's the same as the original macro that comes with MACH3. So I will click on cancel. Notice it's gone through, the tool change light is flashing, and we'll do what we would normally do, click on start, and it continues. So I'll stop this operation and we'll go back to 0, we'll rewind. We'll have a quick look at the macros. There are 2 M6 macros, and I said this is where I think a lot of the confusion arises. The These are the originals that come with MACH3 by default. If we open the first one, just a text file, it's actually written within MACH3 in Visual Basic, but it just has these very simple 2 lines in the start macro and in the end macro. We have a bit more, but I've replaced these with some that do what I want the machine to do. And we'll go and look at the machine in the workshop in a little while, and I'll show you how this all works, but we'll go through the macros first. If you want copies of these macros, then let me know. But the general way that the tool change works, it's important to kind of understand the general operation and the way MACH3 runs this, is firstly, MACH3 does not hand you total control of the machine. There are other processes going on in the background. So sometimes you write a macro and it would seem like it should do what it wants. It may even work when you step through it, as we'll do in a few minutes, in the editor within MACH3. But then when you try and run it from G-code, it doesn't do what you expect. And that's generally because you've kind of misunderstood what MACH3 is trying to do. If we run through this again, we'll start the program. It's got to an M6 tool change command, and what it's doing here is running the M6 start macro, and it will run the M6 start macro and go through whatever you put in there. In this case we'll cancel it, so now that the M6 start macro is now finished, but then the MACH3 is waiting for the cycle start button to be clicked on. When you click on the cycle start button, MACH3 will then run the M6 end macro. But it doesn't do that until you click on the cycle start button to restart the process, which might sound a bit odd because you'd expect it to go straight back into the G-code, but it doesn't. It will run the M6 end macro first. So I'll do that. So just to repeat that, just because it is the basis to how all this works. So we'll click on start, the program runs through till it finds an M6 tool change macro. It then runs the M6 start macro, goes through whatever's in there, and even when that macro is finished, MACH3 will sit and wait until you click the cycle start button, and when you do that, it will run the M6 end macro. So what have I got in those? It's nice within MACH3 you have an editor. So we'll look at, I don't actually want that one, so we'll open the file that we want, and in this case it's our M6 start macro. So what we've got in here is we start by defining some variables, and these are just values we're going to use in the macro. We then get some values that we want to retain. So bear in mind this is normally coming up during a milling operation. So we're part way through a G-code file when we normally run this. So the first thing we do is we save the current X, Y and Z locations. And that's the G54 locations. Now if you're using multiple fixtures and you want to use macros like this, you should really, in fact you will have to define which particular fixture you're using, otherwise all bets are off, the machine will probably just break something. But because here I'm just using the G54 on top of G53, G53 of course being the machine coordinates, then all I need to do is just assume that we're in G54. The G53 command is not sticky, and that is you have to define it on every line where you want to use it, whereas G54 or any other fixture, 54, 55, etc., will stay active until you change it again, but G53 doesn't. It has to be defined on every line you want to use it. Now one complication in doing this is that I want to be able to transfer some information from our M6 start macro to our M6 end macro, because they're running separate. Remember the end macro doesn't run until this one's finished and you then click on the start cycle button. So what I do is within macro you can save to global variables, and I've done that down here. So I've defined all the variables I want at the top, and then down here I've saved the variables I want to global variables. I don't actually need to save all these. This is from a template I wrote quite a few years ago, and I've just used that for this example. But these now will be available to any other macro that's running in this session, and these particular locations are what you might call session variables. They're a bit like a cookie within a web server, so you can look at them in terms of they persist until you restart MACH3. Okay, so as I've done that, so we have access to these values within the M6N macro. So the first thing it does is check to see if the digitizer is available. The digitizer is the digital input, so that's the probe input, and it does that to make sure that the probe isn't already active, because if it is, it won't be able to use it, and chances are the machine will crash and probably break the tool or do some damage somewhere. So assuming that's not in use, if it is in use, it ends the script and doesn't go any further. If the digitizer is not in use, it carries on. So it sets up the general control that we want to use. In this case, it's the dialog that pops up. So the dialog is defined. It just has two buttons, an OK button and a cancel button. We then effectively generate an instance of that dialog, and then we check to see which button was clicked within the dialog. And if we click the cancel button, it sets this variable to 0. And the reason we have to do that is it's one of the variables that's transferred to any subsequent macros. And the reason that I want to be able to do that is because the M6N macro mustn't run or do certain things if the M6 start macro hasn't run. So in other words, if we cancel the operation, we have to cancel it both within the M6 start macro and the M6 end macro. We then wait for a while to make sure everything's settled down and is ready. And if we get to this point, it means we click the OK button, in which case it sets that same global variable to 1. That's just a flag to let the M6 end macro know that it can do its thing and continue. So we save that to the global variable here. It then moves to the safe Z height that we've set in our variable at the top of this script. So it does that because the tool might be down in a pocket or a hole, or there might be some fixture or clamp or something between us and where we're going to move to. So it moves up to what we've defined as a safe Z height for it to move around the table. It then moves to the X and Y location for our touch plate. So we'll look at the touch plate later, but it's essentially, you can look at it in terms of it being a probe. It's what the probe is going to see when the 0 is carried out. Now we're using the tool itself as the probe, or at least the grounding for the probe. So the pad is really the probe just sitting there waiting for the tool to touch it, but it means that we can accurately locate the tip of the tool. So it moves above that pad. It then moves rapidly down to just above the pad, and how far above you move to depends on the expected differences in the lengths of the tools that you're going to use, and again we'll look at this when we look at the actual machine. Once it's got down there, it runs a function within MACH3. This is the G31 function, which is a straight probe, and it probes straight vertically downwards at the speed we've told it to. Again, that was another of our variables. It says F10 here, but in the machine that you'll see running in the workshop, this is an actual variable. Then this is just for testing in the lab. So it probes down to the tool tip, touches the 0 pad, at which point the probe input will be triggered. It then stops, and we then save that position as our original tool change variable. and we save that as a global variable as well. And we'll also throw a message up on the these messages, by the way, are what appear in this status line. So once it's done that, in other words, we've zeroed the current tool, we haven't changed it yet. So we then move back to the retraction distance. The retraction distance is just raising the tool so we can physically change it, because we don't want to try and work around the touchpad that it's just zeroed on. So it raises the tool, gives us some space, lets us change the tool for the new one. And that's the end of the M6 macro. It just puts a message up telling us to change the tool, and then the M6 macro ends, and it's at that point that MACH3 sits and waits for us to click the cycle start button. So it's run that macro we've just seen. It's zeroed the old tool, stored the this is the G54 fixture location, the Z location for the tip of the tool, and now it's waiting for us to click the cycle start button. When we click the cycle start button, as I said, it runs the M6 end macro. So we'll open the M6 end macro, so we retrieve the global variables. We check to see if the cancel button was clicked when the M6 start macro was running. If it was clicked, then we just finish, we don't do anything. If the OK button was clicked, then we continue, and it's waiting here. This is basically where we left off in the start macro. We then assume we've physically changed the tool. This is the point. It will sit in here now until we click the cycle start button. So we use that pause to physically change the tool. Once we've done that, we click the cycle start button, and this then continues. It moves rapidly down to just above the touch probe pad. This is the 0 pad, the same pad it used in the first macro. It then slowly moves down till the new tool tip touches that pad, which will be in a different machine. That's the G53 machine location to the previous tool, or most likely it will be unless the tool is exactly the same length. Goes down till it finds the new tool tip. When it does that, it effectively swaps the new tooltip location for the old one. In other words, it changes the offset in our G54 fixture so that the machine thinks that the tooltip is in the same place, and it then goes back to a safe Z height, so we can then move the tool back to where we want it without breaking anything. It moves back to the work start position. That's the X and Y that we saved in the first macro, and then it moves the Z axis down to the start Z position. Now remember, this is the G54 fixture offset that we're working in, and this is the one we've just updated, so it's not going to move the quill or the milling head down to the same location. It's going to move the tool tip, the new tool tip, down to this location, which is exactly what we want. Once it's done that, it completes changing the tool. That's the selected tool within MACH3, and then it restores some of the status values for the machine, because again, remember, we're part way through a milling operation here, so we've got to make sure that we restore anything that the G code may have modified. Otherwise it could disrupt and cause chaos when the machine tries to continue milling. And once it's done that, this macro ends, and the machine then continues with the milling operation with the new tool in the correct Z position, and the X and Y restored to what they were before we changed the tool. Okay, a lot to cover there, but hopefully that all made sense. So what we'll do is we'll go out to the workshop and we'll have a look at the mill actually doing this. and hopefully you'll see the reason for going to all this trouble. Okay, so I don't know how well you're going to be able to see all this. It's very difficult trying to get everything into the shot at the same time. So I've got a simulated tool. It's actually a piece of aluminium TIG welding rod, just a simulator tool. This is our zero pad. Now the way I have these arranged is it's just a simple metal pad, and I've modified this mill to allow me to connect various probe types, but this just goes to the probe input, and it's on a 3D printed like a little frame here. And if you're wondering what this is for and why it looks so flimsy, it's intentionally designed so that if for any reason, for example, I forget to plug the probe wire in and the tool comes down, it will basically smash the bottom off this and flatten it rather than breaking the tool. And these are sacrificial. I haven't actually broken one yet, but it's only a matter of time. And also have soft limit set so that it will stop before the tool crashes into the table. But it just means that we can save the touchpad itself and the tool if I do make a mistake. And of course, because it just sits in a slot on the table, I can move it around the table to anywhere that's convenient. But you do then have to update the macro to tell it where that pad is. I also have a little template here. I've got several of these depending on which particular template I'm running or which particular macro I'm running, and this is just a tool check. That's the maximum length of tool from the collet I can use before it will smash into the tool holder. As long as the tool's shorter than that, then I know that we are good to go. So I've got the very similar code running on the machine to what we looked at earlier, and it's just a simple rectangular pocket, but I've inserted a few tool change operations. I've got to try and reach past the tripod here, so excuse me if I sound a bit strained. If I switch to machine coordinates, then you'll see that it's reading 000. It's not in that location. That's just what MACH3 defaults to when you switch it on. So using these macros, you do need to drive it to reference all home. So click on that and the machine will just physically drive to the 3 home limit switches. Just takes a few seconds. Otherwise it will use the default values when you power it up, which is where you left off. So now it's done that, it's zeroed, and we can now, and that's the G53 fixture that's zeroed. So notice that the G54, which is the one that we're now looking at, is not zero. Now what I'm going to do, just as part of a test, is we're going to zero on the top of that plate, just because I want to demonstrate how the macro works. So I'm going to bring the tool to above that plate and very close to it. Okay, so I'm just going to leave, so we've probably got, bring it a bit closer than that. Okay, so about 1/10 of a millimetre or so between the tip of our pretend tool and this metal plate. I'll take that out. The reason I'm doing this is because I want to kind of simulate a milling operation, and obviously that will entail the tool moving downwards. And what we do now, of course, we've zeroed to where we want to start the milling operation. Pretend we've bolted or clamped a piece of stock material into the vise. We zero the G54 fixture. So we zero X, Y and Z. I don't know if you can actually read what's on the PC screen. And if we now regenerate the toolpath, we should be able to see what we intend to mill, and we can. That's now come up quite clearly. So we're now ready to start the milling operation. Before we do that, I'm just going to switch temporarily to the G53 machine offset. The one we're interested in here is the Z offset, and it's -85.891. So make a note of that, and we'll come back to that later on when we've tried running our macros. So we'll switch back to G54. So we're now ready to start our milling operation. So I'll click on Start. So the milling operation is underway. This would normally be machining away the material, and at some point we'll get this. It's found a tool change request. This is just what I've just inserted for test purposes. So we can either click cancel, in which case it will just carry on milling, or we can click OK, in which case it will do an actual tool change. So I'm going to click OK so we can see the two macros working. So first it will start by running the M6 start macro. So it's going up to the Z safe location. We'll then move to the plate, go down to the start position, and then it will probe down until it just touches that plate, and then it goes up to allow us to physically change the tool. Okay, so it's now zeroed. It's zeroed this tip in the G54 fixture offsets, and what we're going to do now is change the length of the tool just to simulate a tool change. So I'm going to shorten the tool. Okay, so I've shortened the tool. By the way, the buzzing noise, there's a clamp on the end of the milling table which is making a lot of noise, so just ignore the noise while it's transitioning. I've shortened the tool. We'll check to make sure that it is shorter than our template, which is, as you can see, it's about 5mm shorter than it was. And normally if we try to continue milling without re-zeroing, it would continue milling, but it would do it well above the material we're trying to mill. Now, while we've been changing the tool, MACH3 has been patiently sitting there waiting for us to click the cycle start button. Remember, the MACH3 M6 start macro ended, and it's now waiting till we click the button, at which point it's going to run our second macro, the M6 end macro. So I'll click the start button. It drives down rapidly to just above the touch plate, and then it probes down until it finds the touch plate. When it does that, it will change the Z offset to suit our new tool. It will go back up to the safe Z, move back to our work start X and Y, and down to the Z start, and it will continue milling. I'm going to stop it as soon as it does that. Okay, so it's moved down. I'm going to manually change the Z axis back to 0. So I'm going to just enter Z0. So we now, in theory, should be back in the exact same position as far as the tooltip is concerned to where we started. So I put our plate back in. Remember, there was just a small gap. So we're back now to exactly the same position we were as far as the tool tip is concerned before we started the milling operation. However, if we select the G53 coordinates, that's the machine coordinates, notice that the offset is now -94.451, whereas it was -85.891. So in other words, the whole milling head is lower than it was, but the tooltip is still at 0 as far as the G54 fixture is concerned. So we could now just continue milling, even though the length of the tool has changed after we changed it. The tool tip would still be in exactly the right place. So hopefully that makes sense, and that's how I go about doing tool changes if I use this particular mill. I use this mill a lot. If you're familiar with my website, you'll know I started it when I used to design and manufacture model small gas turbine components. Very high precision, very complex milling operations, and this was a very good way of doing that. Now I also have quite a number of different touch probes for various things, for finding centers of holes, top surface, that sort of thing. If you're interested and you want to see any of that and how I go about it, and also the macros I've written for MACH3 to make use of those, then please leave a comment. If you want these macros that I'm showing here, then again let me know. But hopefully this has kind of demystified MACH3 a little bit and shown how easy it is to make tool change macros. You could modify it to do whatever you want, of course, but I found this is a particularly good way of changing tools because it means you don't have to mess about pre-measuring tools. You can change the tool as many times as you want within the operation, and while it might seem a bit of a slow process to change the tool, if you've done this much, you'll know that that's a very quick way now of changing the tool, and especially as it gives you a very nice repeatable Z offset position when you do it. Okay, so that's it for this video. If you do want me to go over some more detail on the operations of MACH3 and the various macros, then please leave a comment.